Hello everyone, hope you're doing fine. In this video, I will try to explain to you what cubic graphs are about and then how do you sketch. So in particular, in this um, video, I will be discussing particularly about sketching cubic graphs and their modeling, and then not only that, but also how to use the graphs to solve problems, right? So but the main important part is about the sketching first, because that's usually the hardest part. So let me go step by step using this one example. So whenever you sketch a graph, sketching, typically that we need to know the characteristics, right? That's a very typical important note first. So we have to know the characteristics. Now, what are the characteristics in any graphs? From the school curriculum, typically what you need to check is that the intercepts, be it the x or the y. So let me just separate it here: x intercepts, y intercepts, if you have any of them. And then typical features. It depends on what the features are. If it's a straight line, there is no need. If it's a quadratic, the vertex, then probably other stuff like asymptotes, if it's a logarithm or exponential and other stuff. Okay, but then these two are the really important ones. You can add on the next one, asymptote, vertices, or else. Right, but then these two are very important. So in the case of this discussion here, I think there's something off with my rule. Sorry for this. Let me just make sure is everything okay. Okay, great. So let's see in this case. That's why. What are the intercepts? 0, giving you -6, and then if that's for the y-intercept. For the x-intercept, -2, 0, 1, 0, -3, 0. Right. So these are the intercepts that we have. So here, then let's plot it here first of all. So before you start sketching, you always have to know the proper scale, right? So the scaling is also another important thing. For example, what is scale I'm talking about is that, let's say you put the thick like this, because they don't give you one, right? So whenever you talk about the thick, let's say, make sure that they're consistent. For example, if you have 1, then scale of 1, it will be 1, 2, 3, 4, -1, -2, -3, -4, and so on. Then you cannot just suddenly jump. Let's say you say it's a scale of 1 on the right side, but then suddenly it's -2, -4. That's not doable. So you have to be consistent in that sense. And the same is true on the vertical side as well. It will give you exactly the same thing. So here we are. So let's say, because the numbers that we have is pretty small, so in that sense we can try to put a scale of 1 for here. So this is 1, 2, 3, and so on. -2, 1, -2, -3. So here we can have, let's plot it, the intercepts, -3, -3, -2, and 1 as the intercept, right? And how about the y-intercept? So we have 0, -6, meaning going down. So 1, 2, 3, 4, 5, 6, let's say. So here we are, -6, right? So the important part about sketching the cubic graphs is that you have to know, in the sense of what I call as sensible graph. No, so our graph must be sensible enough, and then whenever you sensible in this cubic graph, what it means is that it's kind of hard to put it into words here, but then whenever you see this, the graph will look like this, or will look something like this, right? So you kind of make sure that this part, right, this part and this part, so this kind of like 4 sections, they're all kind of like symmetrical. So I'll teach you by demonstration here what I mean by sensible. So in the case of this, for example, you have 1, 2, 3, and 4 intercepts, right? So The next one that you have to decide is that, because there are two possibilities, so you have to decide, should you go from the lower like this, or should you go from the upper side like this, right? So you have to choose between the two. Now, how do you decide? How to decide the shape? Decide the shape, right? The easiest way to do this is that by using taking a sample. Okay, so what I mean by taking a sample is, let's just make it this way. For example, what we have is that take a sample from here, usually from the most left. Take sample. Take a sample of point. Let's say x equals -4, and then you plug into the given function. So what are the function? X plus 2, x minus 1, x plus 3. So x plus 2, x minus 1, x plus 3, right? So let's plug in y equals -4 plus 2, for -1, -4 plus 3, and then it doesn't really matter what's the value, but what matters is the sign. So here will be negative, negative, negative. It means if you multiply everything, it will be negative, right? So it means it tells you that you should start from the lower, going up, going down, and so on. That's one way to do it. But there is also another way to do it by using your sense, your intuition. But how? So you see from the graph, from the points that we have. If you, let's say you start from the upper, it means you will go like this, right? And you go down, and then you have to go up again beside its intercept. If you take it this way, there will be some point over here that you really have to make the graph going down. Does it make sense? So there will be some point probably here, maybe, that you have to go down again. Then you put until the intercept, and you go up again here. But this wouldn't make sense. Why? There are a couple of reasons. There's 1, 2, 3, 4 intersections with the intercept where the x-axis. Not possible for a cubic. Cubic graphs at most must have 3 intersections with the x-axis, which means in the case of cubic graph, this wouldn't make sense. So with that in mind, it means we have to start from the lower. Now, so knowing that we have to start from the lower, how do we make it a bit more make sense, right? Sensible graph. So you see there, this 2 x-intercept, so you have to kind of make it sensible. Does it have to be like this small, or this big, or like so big like this? That depends. There is no particular tool or formula that we learn in IGCSE that can help us with that. Not like the quadratic function that we can tell the vertex. So what we can do here is that we just make it a bit sensible. So here, let's say it will go like this, because that's pretty small gap. Then you don't have to make it like so big. So it's pretty small. Now this is the typical. This is the problem. The next problem is here. You see the gap is quite big here, but then you have also the y-intercept here. Do you think this is a sensible graph if I make it this way? So it's kind of like long and then like a bit diagonal, then suddenly go down, go up again. It wouldn't be sensible. Why? Because it's like just like all of a sudden like going back up, right? So then I should can tell that there should be a point also over here. So then I need to make it a bit more symmetrical, something like this. Then I go up again, something like this. So it looks good, right? So if you think that this one shouldn't look like this, then you probably can make it a bit, yeah, this one, for example. So that's a kind of sensible graph. So that's kind of like how you do, or how you sketch a cubic graph. Similar idea, you can use it for any type of cubic graphs. So you have to kind of use the sense, aside from deciding the x, y intercept and so on. So that is one example that I can present to you in this video. I will touch on the next part of the section here, using the graph to solve the problems, either the main graph or the modulus, in the next video. Thank you.